Okay, so welcome to this final lecture in this course. I will cover three subjects today. So first, I will go through a little bit about how to handle Python packages and Python environments to kind of make a reproducible scientific environment. I will then also talk a bit about the project assignments, what options you have, and what are next steps for getting started on your project assignments. So first off, Python packages. You probably have already touched upon this when installing things in Python using either the conda command or the pip command. And if you install Anaconda, you have this, let's see here, I can highlight it here. So you have this notion, if you open a command line prompt in Anaconda, you get this parentheses here called base. Base is Anaconda environment, which contains the base installation of Anaconda. So basically all packages that I've used up to now is contained in that package. A problem that you can often arise in Python is that you install packages in this base environment, and sometimes you will get problems by having packages that don't work together, or you have a dependency problem that you can't resolve. You mix conda and pip packages together, and all of a sudden you have an environment that doesn't work anymore. So this is a real problem in Python, that you have this kind of huge amount of packages that all have the dependencies, and sometimes you can't get them to install in the base environment. Python in itself has already solved this in a bit. So Python has a special functionality built in now that can handle setting up self-contained Python environments. So what you can do is, for example, you can use the command called venv, and it's not directly available. What you can do is you can type Python -m venv, and then you name your environment that you want to create. So, for example, my-env. This will create a self-contained environment, basically only with a Python interpreter. So if you press enter here, we'll see what happens. Hopefully something. So if we look in the directory now, you can see here it created a directory called my-env, which contains include files, libraries, scripts for a base package environment. So basically you can see this as a standalone Python environment where you can have a separate package list with installed packages. So what you can do now is to use this environment. So we are still in the base environment here. You can do my-env // So this is a Windows machine, obviously. On a Unix machine, you have the / instead, but it's basically the same. Scripts and activate. On Unix, there will be an activate script. On Windows, there is a batch script here. So now you can see here that you have my-env here. So now this is a self-contained environment, and so if I type Python here, it has a Python environment built in. If you do a conda list here, yeah. With your pip list here, it should be kind of empty. So you can see here you have some packages here available, but basically it's empty. So here you can install using pip your own environment. So for example, I do pip install NumPy. Now you see it downloads NumPy again and installs that in my environment here. So now it looks for, and now you have the pip list. So you have NumPy installed here. What I then can do is I can deactivate this environment again. So my n slash script. Now we're back to our main environment. Again, I have to do pip list here. Now all the packages from our main repository is available here. By using this environment, you can create a self-contained environment that is empty from the beginning. You can even specify which Python interpreter you want in this case. So VM is rather rudimentary, so it's not the perfect solution for this, but most of the other tools that you have are built on this basic functionality. As I always said, packages can be installed in this environment using the Pip Command tool. So this is the Python package repository, and the command to use is the Pip Command. It has a lot of options here, but to kind of look at the packages here, you type pip list, you get the packages that are available, and then you can do pip install as well. And then the package name. You can find all the packages you can install. Can we find? Let's see here, pipey.org. This is the central location for all the pip packages. Here you can also search for packages. So, for example, I go in and search for NumPy. You will get all the packages available here. So, if you use the standard environment, this VM. The only way to install packages is using the pip tool. I will show you other ways of installing more packages if you are using the conda tool as well. But this is the basic functionality, and pip is the main package repository for Python. So again, I would do another Python environment here again. Python. So what I'm going to do now is I'm going to try to create a reproducible Python environment. So then I do my proj /scripts. Wait.
Excuse me.
Yes.
When you install packages in an environment, it's for the possibility to import them when we write a script. Or if we don't have a package installed, we can still import them at the beginning of the script that we write.
Yes, so I understand here, but so if you create an environment, it's kind of empty from the beginning.
Mm-hmm.
You install the packages, and next time you activate it, all the packages are there. So it's available.
So that's the use for that is that when we write a script, we do not need to call those libraries, or I mean.
So if you write your own scripts, you need to make sure that environment contains the packages you need for your script. So the import statements, those are kind of what packages you require. So you need to make sure if you create a new environment that you install all the packages is required. The nice thing with this is that you get only the packages that your scripts require. So you get a kind of self-contained environment with not too many packages that you have like in the base environment. Base environment has all pre-installed. So this can be useful if you want to make sure that you can recreate exactly the environment for your script on another site.
Mm-hmm.
So basically what I will show you now is that you can actually create a description exactly of this environment, which you can take and use that to recreate that environment somewhere else with exactly the versions that you have installed. So for example, if I install here now, pip install, it's a package that I have developed for another course. So You see here, it depends on NumPy, PyVTK, and some other things. So now these will be installed in the myproj environment. So you get exactly the dependencies installed and nothing more. Takes a bit, it's a lot of dependencies here. But so what you can do then is that you can list these requirements and put them into a file, which I will show you in a second here. Yeah, it will soon finish, I hope. So now you see it installs the package. First, it looked at the requirements for this package, and then it downloaded all the packages, and then it installs the packages separately in my environment here called myproj. So now all the packages installed. So if I do pip list here, you can see all the packages that was installed now and is available in this environment. So you see also that I have it also installs it should be a Python version here somewhere. But you have a specific version of Python as well here. What you can do now is, if you want to tell another user how to install this package on a different system, you can use the Pip Freeze command. Pip Freeze. That kind of makes sure that you get a snapshot of your environment with all the versioning. So I'll put this to requirements. If we look at this file now, we have a requirements text. So basically you get a list of all the packages here with exactly the version numbers that has been installed. So now you can recreate this in a different environment. So what we can do now is we do myproj scripts, and we do deactivate, and then we do Python -m and myproj copy. Then we do we do pip list here. You see here that we don't have any special requirement packages here, only pip and setup tools. I don't know why code from Python is here. It's something in my installation. Anyway, we can then, from that list of packages, you can actually create another environment. Oh, okay, now I did it in the wrong way. Yeah, no, I'm correct. So I do pip install -r. Then we go back to the my project. Then we have the requirements file here. Oh, sorry. No, there it is. Pip install -r requirement. So you can tell Pip that I want to install these packages in my current environment. So read the requirements from the file, and then I can recreate this. And now you can see it will recreate that environment for me directly here. Now it also uses the packages that were previously installed, so hopefully it should be faster this time. I will break it here just to. We will create all the packages here in this copy here. So this was the basic tools that are available in Python. So I will just it's a bit cumbersome to use this vn command. So what you can do instead, there is another tool that is a bit better to do this. It's called pip end. And you can install this in your base environment because you need to have it somewhere. So pip install pip end. This is a command line tool that is a bit more sophisticated, and it's more gears to if you're working on a single project and you want to have a project directory with the required Python package in that directory. Pip env is a good tool to do this. So what you can do then you create a project directory for your project here. So it's an empty directory, and then I do pip end install, and then it will in that directory create an environment for you. What is this?
Can you hear me?
Yes.
But it's not obvious to me what the difference between a make directory and a virtual environment is. It looks just like a folder where you put in your environment packages.
Sorry, what the difference is between?
The virtual environment and the make directory. I mean, they both just look like folders where you put in your packages.
Yes, so what the VM does is it creates a directory with the same kind of directory structure as the main Python installation, but only with your own packages. And I don't know why this one crashed now here. It should have worked, but pipm is more if you already have source code and you want to provide a Python environment for that source code, you can use pipm to create the packages in your own directory. I will show you. I have this is from my. I have a documentation. We'll get a link to this as well. But here you can see I create pipm install. Then it creates the virtual environment for this directory, and creates the files and the packages in that. And then you can activate this environment. And use and it will all be installed in this directory. So it's one option here, and then it also creates a pip file that contains the description of the installed package that we can use to recreate this environment on a different location. But I think I will go to how you do it in Conda instead, because I'm not sure I can get this to work now. It worked before. So if you're using Anaconda, I will try to open another one here just to make sure it works. So in Anaconda, it's also possible to create environments. And there's a tool for that. So if you have Conda installed, you can do Conda create -n, and then you specify the name of your environment here. So test one. This will create a completely empty environment. It doesn't even have a Python interpreter by default. Yes. So if I do, so now I have I can execute Python -b. So there is a Python environment here. Conda activate one. Yeah, so now you see this is what happens on Windows when you don't have a Python environment. It tries to start it, but it's empty basically. So the first thing you have to do is install a Python interpreter here. Python equals to, let's see, 3.9. So I can specify here a different Python interpreter. So now it says to be able to use this Python, you need to install all these tools here. So using this environment, you can create an environment, for example, with a specific version of Python for specific package that will require, for example, a 3.7 or 3.8, or if you have an older version of Conda, you can actually install a newer version of the Python interpreter. So if we do Conda list here, you can see here that I have an environment with only these packages installed. If I do Conda deactivate to go back to the base environment, and I do Conda list here, you will get a lot more libraries or packages. So Conda activate first one. And you can also, if you want to create a specific environment, you can do Conda create -n. Test2, for example, then you can specify directly here that you want a specific Python interpret. Python equals to 3.7, for example. And then we create an environment with a base Python 3.7 install. You can remove an environment. So if I don't, Conda deactivate. When you deactivate, you don't have to specify any environment. You just press Conda deactivate. I'm back. I can do Conda remove -n. Then we do test one. That will remove all the packages here. So you can also list the environment. So if you do Conda and list, that will list all the available environments that you have created. So here I have several that I use. So now I'm in the default one. It's base. I can do Conda activate open dev and do Conda now. It should show you which environment is active here as well. So now you see a count from there. So the Conda command is available everywhere. So Conda deactivate. It's also possible to clone an environment. So, for example, I can do conda rate minus n, and then I do call fem dev2 clone call fem. That will create a new environment based on the packages in the call fem dev environment. So, for example, if you're developing, my usual workflow is that I create, when I do some development, I create a clone or I create a new environment, and then I install the required packages there. So if there are some problems, I can just remove it and restart again and create another environment. So they're completely self-contained. So there, you can see there's a lot of files involved in the packages. So there's only 11 packages, but there are 14,942 files. So you do conda and list. You should have a call from dev2. So conda. So here we have the packages that are installed here. You can also, so if I go into conda, I will create a small conda. So this is the, so now I created a test2 environment. What I can do now, if I want to export this environment to somewhere else, I can use the conda list, and then I do test2 explicit. I'll go to spec file. So if you look at this file here, you see here that I get a different list from the we're using normal Python environment. You see how, but you still have all the packages required to build this environment. Conda deactivate, conda rate minus n. Specify a file and a spec file here. So now I want to create a new environment, test3, that uses the packages that I specify in the spec file. And then conda activate. Now you have the same packages as we had for the test2 environment. So in this way, you can actually, from an environment that you created for your software, you can create a package specification that you can use to recreate the package environment for your software identically on a different platform. So if you have developed, for example, your code on your own machine, if you want to run it on the Linux machines, but you want the same packages, you can take this spec file, recreate the entire environment on the Linux systems, and then you can run your code there. There's also one thing that I usually don't recommend mixing Conda package installation with pip installations, but sometimes the packages that are available in pip are not available in Conda, so you're left kind of with the only option to use the pip command to install packages. But what I usually do then is, by using a Conda environment, you can shield yourself from problems related to pip and Conda incompatibilities. You create an environment. If it doesn't work, you can just remove it again. But try to avoid installing pip packages in the base environment, or as few as possible, and then use the Conda environment tool to create environments where you can mix both Conda and pip packages in a single environment. So installing pip here is no problem. So you can combine pip installations with Conda installation in an environment that you have created. So that is a good way to kind of use both worlds, but without messing up your base installation. There's also a possibility to, if you want to use environments with Jupyter notebooks, you can do. What you have to make sure, if you want your environment to be available to Jupyter Notebook, you need to install something called an additional package to your environment. So if I want, for example, to make test free here to be available in a Jupyter Notebook, I can do Conda install kernel. That adds a lot of packages to your environment, but that also makes it available to run this environment, to switch environments in your Jupyter Notebook to use the packages that you have specified. I will show you shortly how you can do that. So now test free is enabled for notebook use. So Conda deactivate. Then I start a Jupyter notebook. Here you can create a new notebook here by pressing new, and you can now see that I have a different environment here. So by using this iPad kernel, you can actually add kernels to your Jupyter Notebook that you can use. Another option would be to install the Jupyter Notebook command in your environment as well. That's another option. So that was a bit about the Python environments. I think you should keep this in mind here. I mean, most of your code you can develop in the default Anaconda installation, no problem. But if your code is getting bigger, or you have to maintain codes on different platforms, and it could also be that, for example, the next version of Anaconda has a different set of packages that are not compatible with your code, then you could have a problem. By using Conda environments, you can ensure that your environments or packages required for your program is consistent, and you can move them between platforms. You can also, inside a Conda environment, you can update the package just like you do in normal Conda. You can do Conda update, and you can do that inside an environment as well to update the installed packages in the environment. So that is also possible. So that was about environment. I will put a link to this document about the Python development environments in the course page as well. So now I'm going to talk a little bit about the project assignment.